Hey guys, very quickly, we just want to start Module 11, Security and Network Design. I'm going to go through, hit the highlights, and hopefully uh, give you the things that you will need to look at for the quiz. Don't forget, this information will be on the quiz, but it'll also be on the final exam and the or this one won't be on the midterm, but the others, modules 1 through 7, will be on the midterm. So be prepared for that. Let's go ahead and get started. Okay, so here we are. Module 11, Security and Network Design. The module objectives incorporate security in the design of a network. Very important that you start building security in from the ground up. Describe the functions and features of various network security devices, can be firewalls, routers, etc. Explain how authentication, authorization, and accounting work together to help secure a network, and then compare the different authentication technologies. Zero trust. In that security model, everything on the network is considered untrustworthy until it logs in, authorizes, or proves itself otherwise. Routers, switches, servers, every device on the network are at risk from malware, malicious users, intruders, bots, or unintentional errors. All of those things are possible, so zero trust is actually a very accurate model. Security must be implemented in redundant layers because that's the only way to protect the network and keep it from accidental malfeasance or intentional attacks. A router's main function is to examine packets and determine their destination. Access control lists are used by routers to decline forwarding certain packets. That means if it's on the list and the router doesn't like it, it will simply discard it. Each time a router receives a packet, it does one of the following, and I'll let you go through that list. If the packet doesn't match the criteria, then the packet is dropped. That's the implicit denial rule. It errs on the side of caution. These are the different tests. Usually there's 3 tests. If it's yes to any one of these, it'll be allowed to move on to its destination. If not, then it will be dumped. Access list, that's a Cisco command. It'll assign a statement to an already installed ACL. That means if you want to add a new source or a new destination or a new service or anything like that, you need to give access to it by putting it on the list. They do affect router performance. The more tests you have, the slower your traffic is going to move. Control plane refers to the decision-making layer of a connected network device. And control plane policing is a feature that can be used to rate limit traffic. This can protect you from a lot of different things. Still, it works with the ACL. So you're still going to have to, you can still configure it that way. The class command entered in PMAP configuration will pair the class map you just entered with your new class, with your new policy map rather. And this is an example of one here. This is router configuration commands. Router advertisement guard. Basically, you never know. There's no way to prove or authenticate a router advertisement message. And so basically you can have malicious messages can be used to misconfigure client networks, and then high volumes of router messages can create a denial of service attack. So you have to be very careful with that. The guard feature filters router advertisement messages so they can only come from a specific interface on the switch. That means the one that the router's hooked to, and then also offers other criteria you can use to filter these messages as valid. You can even put in like a keyword so that nothing will get passed that doesn't have that keyword in it. RAGguard is the command in Cisco that will let you configure or reconfigure those advertisement messages. DHCP snooping. A rogue DHCP server running on a client device can implement an on-path attack, and you don't want that. So DHCP snooping is a switch feature that can be used to configure switch ports connected to clients to not transmit DHCP responses that should only come from a trusted server. So you basically build an access list with your DHCP server IP addresses, and then the only DHCP messages that'll be forwarded have to come from those IP addresses. And basically you're using IP DHCP snooping, and that in a Cisco router or switch rather will set up that that ACL or that access list. Excuse me. Okay, dynamic ARP inspection prevents ARP spoofing attacks. I'll let you look those up, but just know that it's available. Proxy servers. Basically, a proxy server acts as a gatekeeper to the internet. So you're actually, if you're hitting a proxy server, you're never getting out to the internet. What you're doing is sending a request to the proxy server. It forwards your request out to the internet. It gets your information and it sends it back to you specifically. It never lets you get outside of the company router. It acts as a proxy for you. So this is good. It's a good way to protect yourself. Basically, nothing can ever get through to you because it'd have to go back through the proxy server, and that can't happen. You can set up a reverse proxy. I'll let you read about what that is and what's involved there. Yeah, basically what you've got here is a workstation hits a switch, goes to the router, and makes a request to get to a website like Microsoft.com. Well, the router flows all traffic that is requesting website access. It sends it all to a proxy server. The request, along with your identity, is held there, and the proxy server makes a new request and sends it out to the internet. When that information, that website is found, then the response comes back to the proxy server, who remembers your ID from earlier, and it sends your website to you. Basically, you're browsing just like the proxy server was a web server. It caches whatever information you're asking for. It slows things down because you're having this extra layer of intermediary there. So you have to wait for the proxy server to make a request and get a response back and then send that response to you. It is a little slower, but it's a great deal safer. It's actually a good way to secure a network. Then firewall, stateful packet firewall, specialized devices or software that selectively filters. I'll tell you right now from experience, software firewalls, if you have that on your computer, that means that the person you're concerned about breaking in has already broken in and they're inside your network because your computer is where the firewall is located. You need a firewall between your network and the internet. That's a specialized device. It's a separate device like a router, or it can be built into a router. But if you're depending on a firewall inside your computer, that means that the bad guys have already broken in because they're hitting your computer now instead of a router or a switch or something like that. So you definitely need to have your firewall between the internet and like right here, most commonly a firewall is placed between your private network, which is your corporate net or your school net or whatever, and a public network like the internet. Otherwise, it's pointless. Packet filtering firewall is a very simple type. That's a network device that examines the headers, and if the headers aren't right, or if they've been spoofed, or if it finds any questionable content in the packet, it just discards them. Common criteria that they work off of: the source and destination IPs, the ports, the flags, anything that the TCP packet header has in it. If it looks the least little bit hinky, then the packet filtering firewall will just dump it. It'll never get to its source. Port blocking prevents the connection to or the transmission of information through blocked ports. You can also use a firewall to do encryption, to do authentication. You can use it to manage your network and control things like traffic and load balancing. You can set up access rules. It's very easy to do port forwarding. If you've got a public IP address on the outside of your network and then you have one server inside your network that you want to certain kind of traffic to go to, then you could set that up in your firewall. Protect the internal LAN's identity. Basically, it prevents anybody on the outside from finding out anything about the interior. Stateless firewall manages each incoming packet as a standalone entity. It doesn't care about what else has come in. So this is actually a good way to protect your network. It has rules similar to the ACL rules, but it has a little bit more control about what gets filtered. You can be more specific with your rules, and they can also check a deeper. They're not just checking the identity; they're also checking the port that it's going to, the protocol it's using, to even the subnet mask that it's using. So firewalls are a lot more powerful than an ACL. Troubleshooting firewalls. Most commonly caused firewall failure is misconfiguration, user error, and that's the truth. Firewalls are fairly simple, but they are complicated to use. You have to know what you're doing. That's why you spend a great deal of time in network configuration classes and network plus classes like this. In fact, there's a whole class just on firewalls, just on how to configure firewalls, and it's certainly one of the more complicated ones. However, it's also really, really valuable to employers. So believe me, it's a good certification to have. When you make exceptions to the rule, it's called punching a hole in the firewall. You can imagine that punching a hole in a firewall is never a good thing to do. It has to be done carefully considered before you do anything like that. Intrusion detection system. It allows you, specifically looks for hackers, other kinds of intrusion besides just packets. It monitors network traffic for things like extreme traffic going out to one particular node that shouldn't ordinarily get that much traffic. It's looking for specific patterns of traffic, and when it does that, then it will alert the network administrator that something's going on. Can only detect and log suspicious activity. It does not block anything. It's not like a firewall. It just sends an identification, or it sends a message with the information that it has to the network administrator. Intrusion prevention system, on the other hand, can block things. When it's alerted, it reacts. It can block traffic or redirect traffic. Now I'm going to let you figure out the vocabulary. Cloud platforms. This is not, there's not enough time to have this discussion, but cloud platforms have a great deal of security concerns, as you might imagine, because cloud platforms are inherently shared. There are inherently a lot of users in a cloud platform, and so to keep all that data separate, because it's basically on the same hard drive. You don't get your own hard drive on the cloud. These drives are encrypted and partitioned and divided up, but essentially you're sharing drives with everybody else, with every other customer. And occasionally someone else's data gets exposed, and that's a bad deal. So cloud technology is not perfect yet. It's reliable, but there's still issues. So that's a thing to consider when you're using the cloud. There are still some services that government regulators, for example, won't let you put on clouds because the data security is just not quite up to what it needs to be yet. So cloud platforms have inherent security issues. Which device can be used to increase network performance? By caching websites. So we talked about that a while ago. It acts as a cache, and then you browse the caching server rather than the real website, and that's a proxy server because it can help. Now, they say it can improve in performance, but it also really degrades performance as well. My experience has been exactly the opposite. If it caches the information, if it's a website that you go to frequently, that's a good thing because then it's basically like your computer. It caches the web files, and it can go back there as long as there's not any changes. But the first time that changes, the caching server, the proxy server, has to download all the new information, and then it has to send you a message, and you have to go download the new information from it. So it can also degrade network performance. Authentication, authorization, and accounting. Those three A's, you need to know the definition of each. Authentication, a user can be authenticated to a local device or to the network. Basically, you can log into your computer, but if you're on a domain, you also have to log into the network. Username and passwords are stored locally. That means locally on the network, not unless it's just a standalone machine you're operating on. That's really low security. Convenience, well, it just depends. And then reliable backup access, because it's easy to back up a single machine. With local authentication, every computer on the network is responsible for securing its own resources. Yeah. In Windows, you can switch from local to network authentication using the System Properties dialog box if you have Windows Pro. And Windows Home will not do that. Windows Pro will let you switch to a network authentication. You can join a domain, but on Windows Home, you're stuck with local authentication. You can harden your network by requiring secure passwords. In fact, if you're using Active Directory, you can go in and set the policies for passwords, and you can really harden your network. You can require 100 characters, randomly generated mix of letters, numbers, and at least three exclamation points. You can basically do all kinds of things to set the security level of your password. The problem with that is you can go too far, and people are like, you know what, I'm not gonna even try to type in 100-letter password. So you can see the problem. You can also set up restrictions for time of day. That means between 8 and 5 people can log in your network. After that, you have to have special permission. You have total time logged on restrictions. If they've been logged on for 2 hours or 3 or 5 or 6 hours or whatever, then it logs them off automatically and won't let them log on until tomorrow. Source addresses, they have to have the right IP address. If you give them 3 unsuccessful attempts, then lock their account. And also geofencing, you can use. It's not perfect, especially not if someone's using a firewall, or not a firewall, I'm sorry, a VPN, because you can make yourself look like you're in a lot of different places. But for the most part, you can get the geographic location from what they're logging into, what ISP they're using, and at that point you can say, okay, well, if this is from Russia or China, then you can't log into my network. Authorization, this is how much privilege you have. The rule for all network administrators, and I guarantee you it's going to say this here shortly if it hasn't said it already, the rule is the least amount of privilege that you need to do your job. So you give everyone the least amount of privilege that they need. So now some people are going to need to be administrators, but you want to limit that number to the absolute minimum. And then you also want to compartmentalize the administrators, make one the administrator of Active Directory and one the administrator of network security, one different administrators in different roles. You want to compartmentalize so nobody has all the power except for one person, and that's the network or the domain administrator. With role separation, compartmentalization, what I just said, each user can only be a member of a single group, and that way you don't have too much power. Separation of duties, the division of layers, no labor ensures that no one can single-handedly compromise everything. Sensitive privileges are distributed to multiple people. Log file viewer can be installed to make it easier to monitor logs and check out suspicious activity. In Windows, the event viewer is not the most friendly tool. There are other third-party tools that are a lot easier, and you can even set up alerts so that if something does happen, you get an alert from your viewer, which is monitoring the log files all the time. Directory services. This is Active Directory in Windows. OpenLDAP or 389 Directory Server, these are different tools, but mainly most people in a Windows domain are going to use Active Directory. Lightweight Directory Access Protocol, that's the protocol for accessing an existing directory, and also Kerberos it allows you, it checks the time to make sure that your times is synchronized. There you go. Cross-platform authentication protocol that uses key encryption to verify a client and securely exchange information. If you try to log in with the wrong key, that's a public or private key, or if the time is messed up, it will boot you off. Principal key distribution centers and tickets. You get tickets. They're access tickets. They're digital, by the way. There's not paper tickets. But the ticket granting service sends you an access lease, and basically it allows you to log in based on your network credentials. Single sign-on. This is what we use here at Grayson. If you're an employee, essentially, if you're an employee here at Grayson, like if I want to log into my computer, so I put my username and password in, I hit log in, but then it takes me to a deal that sends a push message to my phone. So the first form of authentication is username and password, but then I have to have my phone on me because I have to be able to respond to a push message and click a button. So I have two forms of authentication, but once I have logged into that, then I'm logged into any service that Grayson offers. For example, if I log in, then I can go to Gmail and access my Gmail from my Viking, and I'm already logged into that because I'm logged into Grayson. Or I can go to Office 365 and access my benefits there because I'm already logged into Grayson. So single sign-on means you sign into one page, and now you have access to all of your services that are available. And then two-factor authentication is I've got to have my phone with me. So factor one is I log in. Factor two, I respond to a phone message. Authentication factors, something you need to know, a PIN, something you have, use a smart card. Basically, it's like a credit card. You can use fingerprints, facial recognition. You can geofence, you can set it for location, or you can do voice activation even. You got to have at least one authentication method in addition to username and password. And then a security token is generated. These can be stolen, by the way, so you have to keep an eye on this sort of thing. Radius, I'll let you look up the vocabulary words. Also, TACUS. All right. Which authentication protocol is optimized for wireless? And that's going to be Radius, because it supports clients not directly wired into the network. All right, that is Module 11. So our summary: incorporate security into the design of the network. You need to build in and start thinking about security when you're building the network. It's a lot easier to build it in than it is to come back and add it. Describe the functions and features of various security devices. We talked about firewalls. We talked about intrusion prevention and intrusion detection. We talked about ACLs and different things. Explain how authentication, authorization, and counting work together. You need to know the differences. And then compare authentication technologies. We talked about smart cards. We talked about the different kinds of ways that you can authenticate onto a computer. So that is Module 11. All right, guys. Hey, I changed shirts. How weird was that? Actually, it's a little bit later in the year, but thank you, one and all. That was Module 11, and so we have one more module to go. We have Module 12, and that will be next week. For this week, make sure that you get the chapter quiz done. Remember, I'm counting the attendance based on your participation in the online part of the course now that we're not actively meeting every week in class. So also remember that I'm still coming to class every Monday night, and if you need help, then show up and I will answer any questions. We'll go through anything you need to go through, but if nobody shows up, of course, then I go home. So Module 11 is done, and next week will be Module 12, and that will be it. After that, we'll start reviewing for the final. There are 2 final exam reviews available online. You can go through those. The questions will be pulled directly from the Module 6 through 12 chapter quizzes. So if you want a really good source that has the exact questions, and I'm not going to tell you which questions, but of the 100 questions on the final, a lot of them are, they're all going to come from those 6 quizzes. So go back and look at your quizzes again. And also, in conjunction with that, use the review sources that I've placed with the finals in the modules, and you should have no trouble at all making a 100 on the final. Glad you've been in class. I look forward to our last week. If you have any questions, I can be reached at grayson.edu, or more specifically and preferably through the Canvas inbox. So let me know how things are going, and I look forward to talking to you next week. Have a good day.